All right, today we are going to learn about exponential graphs and their transformation. So we've already looked at exponential growth and decay. Now we're kind of looking more at the straight algebra part of it. So we just got done in Unit 6 studying a whole bunch of different parent graphs with the sine, the cosine, and the tangent, and you had a bunch of different patterns to memorize. Now, the exponential function is the first function we've studied that has more than one parent for just an exponential. However, it's actually going to be a little less work than the trig functions because even though there are an unlimited number of parent graphs for exponentials, they all have the same pattern. So the parent pattern that you are going to need to know, we're going to write down over here. And it goes -1, 0, 1, and then 1 over b, which means the reciprocal of b. We did this a lot in Unit 6, and then 1b, where b, if you look at the general function, is the base. It says right here that the parent takes the form b to the x. So it's important to note that in this type of parent graph, B is the base, not a transformation. So that means that on these, we're not going to have any horizontal shrink and stretch like we did with the trig graphs. We're just going to have, we have A, which controls vertical stretch. Remember that that happens if A is greater than 1. It's a vertical shrink if A is between 0 and 1. If A is negative, there's going to be a reflection in the x-axis. Hopefully all of these transformations seem very familiar because they're the same ones we've been doing all year. H, just like it always does, controls horizontal shift. And same as always, if it's negative, it goes to the right. And if it's positive, it goes to the left. You can see where all of these are located. Notice that H is located up in the exponent, whereas K is down on the same level as the A and the B. K controls vertical shift. And just like on all our other parent graphs, if it's positive, it goes up. If it's negative, it goes down. So just like always, the parent graph, the original graph, is what we're going to start with. Notice that in this example, it asks us to graph the parent and describe the transformations to get g of x and then graph it. So we're actually going to do two graphs on here. One for the parent, which is our f of x. And then we'll describe the transformations and write out what we would have for our g of x. So in this case, here's our f of x. You can see that matching the formats that b is 4. So that means for my parent pattern, if b is 4, 4 goes here, 1 goes there, it's always 1, and then the reciprocal of b goes here. So the reciprocal of 4 would be 1 over 4. So this is my parent pattern. The parents are always graphed from the origin. So that means I just am plotting these points as if they're just a regular table, a regular t-chart. So I go left 1, up a quarter. So it's kind of hard to only go up a little, but we try. 0, 1, so that's here. And then 1, 4, which would be right here. Now, the shape of an exponential, in this case, looks like exponential growth when we connect it. And you could always graph it in your graphing calculator to check your work. Typically these are non-calculator transformations on the non-calculator parts of quiz or test. But while you're doing your homework, obviously feel free to use your graphing calculator. Remember that Desmos is a good online resource if you want to use that to check your work with your homework. All right, so now we're going to describe the transformations. And here for g of x, I have an a value. I have something multiplied in front that's 1/2. So 1/2 is between 0 and 1, which means here that's a vertical shrink by factor 1/2. Then up in the exponent, I have this -4 up here. Tells me that that up in the exponent is an h value. So since it's negative, that tells me I'm going to go right. So that means I have a horizontal shift right 4. Then the last thing I see changed from the parent to my g of x is this -2. I match up here and I see that that is a vertical shift value because that's a k value. So in this case, since it's negative, that means it goes down. So vertical shift down 2. All right, so I've done 2 of the 3 things it asked. I graphed the parent, I described the transformations. Now I need to actually graph g of x. Now when we do these, just like with the trig graphs, we are going to take our shifts first and kind of mark it with a plus sign. So in this case, right 4 down 2. So right 4 down 2, and I'm going to mark it with a little plus sign, because that is my new start point. That's like my new origin. Once I've done the shifts, then I'm going to look and see if I have any type of a value, because if I do, that's going to need multiplied by my vertical column, which this is the same thing we did in Unit 2 with the parabolas. So in this case, a is 1/2, so multiply all my vertical column by 1/2. And so what I get for g of x, now keep in mind that this is not a set of ordered pairs from the origin, it's a set of movements from that plus sign. So what I get there is -1/1/8, 0 1/2, and 1 2. Those are movements from the plus sign. So I'm going to change my color again here. And so I go from the plus sign, left 1 up 1/8, then left none up 1/2, and right 1 up 2. And it should have that same exponential curve shape right there. So this is my g of x. My original here was my f of x. So that's how we do the graph. Now we're going to look at important characteristics. So remember, a lot of you seem to struggle a little bit with understanding what increasing and decreasing means. Remember that increasing and decreasing is a description of what happens as we go from left to right. So in this case, as I'm moving my finger or my tool here from -infinity to infinity, my y values are getting bigger. So that means that on this parent getting bigger, it's increasing. On the transformation, same thing. I'm tracing and it's going up as I move to the right, so it's increasing. All exponential functions have a horizontal asymptote, and the parent graphs, let me give you a hint, it's always the x-axis or y = 0. If you look at our transformation at g of x, its horizontal asymptote is shifted down 2. So this is really important. Now that we know that that's there, every time we draw our plus sign, just like what we did with the trig functions and midline, we're going to draw in that horizontal asymptote, because remember, we don't want our graph to cross it or touch it. The horizontal asymptote always corresponds with my vertical shift, just like your midline did on the trig graphs. End behavior is x approaches infinity, meaning on the right. So in this case, on the right side, both f of x and g of x are going toward infinity. So f of x approaches infinity, and g of x happens to do the same thing. End behavior as x approaches negative infinity. That means what's happening on the left. Where is the y value going toward? And this is the first time we've had a graph that approaches a value that's not an infinity. As I go to the left, those y's are not getting closer and closer to negative infinity. They're getting closer and closer to 0. So we would say f of x approaches 0 because it's approaching that horizontal asymptote. Whereas on the transformation, as I go more and more and more to the left, my y's are getting closer and closer to -2. X-intercept, where it crosses the x-axis. If I look at the parent, it doesn't because it has a horizontal asymptote there, so there are no x-intercepts. On my transformation, however, I do see a very clear x-intercept there at 5, 0. Y-intercept on this guy, it's a very clear 0, 1. On my transformation, however, it's not clear where it is. I know it's above -2, but I'm not really sure where. Now, we could find that actual value by solving algebraically or using our graphing calculator, but you're never going to be asked to find that on this type of question because typically these are non-calculator. So what I would really do is just do an estimate. I would do 0, and then I would just write -2, and then plus, which just means it's a little bit bigger than -2, and that's good enough. Or you could even just do an approximately symbol, 0, approximately -2. We know it never gets there, but it's pretty close. Domain on these exponentials, another thing that you can always count on. It's always -infinity to infinity. So those should be freebie points. You just fill them in. It's always -infinity to infinity. The range, however, is going to vary based on what kind of parent we have and what kind of transformations we have. So my y values on my parent, they go from 0, not including 0, up. So remember, if we're not including, that means we use a parenthesis. So 0, 2, and since it's going up infinitely, we would say infinity on the range. Now, for the transformation, lowest y value here is just above the horizontal asymptote. So that would be -2, but again, not including. So use a parenthesis, not a bracket. And then it also is then going up infinitely. It's got an arrow. And so we would say infinity there. All right, going to walk you through one more complete example, just with a little different situation. So hopefully it gives you enough to be able to do your practice problems. So here's my f of x, got to make its table, and pattern is always the same, -1, 0, 1, 1 over b, so meaning the reciprocal of b. In this case, b is a fraction, b is 1/3, so the reciprocal of 1/3 is 3. It's always 0, 1, and then 1b. b is 1/3. So here are my values. Now I'm going to list my transformations. All right, so when I look at my transformation, I see I have a negative in front. Remember that anything multiplied in front is an a value. So this is telling me right here, that's saying a is -1. So the 1 itself doesn't cause a change, but our second bullet point, if a is negative, there's a reflection in the x-axis. So that's what we need to write out here. Reflection, x-axis. Notice that this time there is no h value up here, but there is a k value down here. It's positive, so that means we've got a vertical shift up 4. All right. On the original, we would have -1, 3, 0, 1, 1, 1/3. So notice that in this case, we have an exponential decay. So we're decreasing as time goes on. So now I'm going to plot my little plus sign. In this case, I only have one shift and it's up 4. So my little plus sign, my little start point is going to go right here. Remember what I said on the last one, that wherever you draw your plus sign, right through it, you can draw your horizontal asymptote. That is where that's always going to go. So now I need, once I have my plus sign, to make my adjustments to the pattern. We only adjust the pattern if we have an A value. And when we have an A value, we multiply this right side column by A. So in this case, we're multiplying by -1. So that gives me -3, -1, and -1/3. So this is my g of x. Remember that these are plotted from the plus sign, not from the origin. So -1, that means left 1, down 3. 1, 2, 3. 0, -1, that goes here. And then 1, -1/3 goes about here. So in this case, we've got something that looks like this. So big changes when we've got that reflection. All right, so now we're just going to fill in the key features. So the parent, my original graph that's in black here, as I go from left to right tracing, it is getting smaller. So that means that it is, decreasing. The transformation, as I trace from left to right, those values are getting bigger. So that means it is increasing. Horizontal asymptote, I told you the parent, it's always y equals 0. On my transformation, it goes right with my vertical shift, which was up 4, so y equals 4. End behavior as x approaches infinity. So original graph, as I move to the right, the y values are getting closer and closer to 0. So f of x approaches 0. On my transformation, as I move toward the right, my y values are getting closer and closer to 4. Oops, shouldn't be f of x, should be g of x approaches 4. Notice how we always have one that matches up with the asymptote. On the left side, my original graph, as I trace to the left, is going toward positive infinity. So infinity. And my transformation is not. As I go to the left, it's going toward negative infinity. So see how, depending on our transformations, things don't always match each other. All right, x-intercepts. On my original, there isn't one because it does not cross the x-axis. On my transformation, its x-intercept, I know it has one, but I don't know what it is. In this case, it looks like it's pretty close to maybe -1. So again, we could find it with a lot of algebra or graphing calculator, but that's not really the focus of this lesson. So we're just going to say 0, or not 0, we're going to say approximately -1, 0. Because it's close. It's a little past it, but close enough. Y-intercept on the original is at 0, 1. On my transformation, you can see it very clear right here because it was 1 unit down from there. It's at 0, 3. No surprises. I told you this would always be negative infinity to infinity, so those are gimme questions. And then the range. So on the original, It again, lowest value is close to but not including 0 and goes up, so infinity. The transformation, however, its lowest value is negative infinity because we've got an arrow going down, and its upper limit is the asymptote, which would be, in this case, at 4. All right, so you've got ideas, instructions for how to graph, key features to find. Make sure you check in with your teacher for office hours for questions.